Hello, this is Mr. Collier, and today we're doing line of best fit and linear regression with the TI-84 calculator. So here we have a set of data. We have predicted height of daisies versus actual height, and we want to see if there's a relationship there, basically determining if these are good predictions or not. Okay, so first we're going to do a line of best fit by hand. That means we need to do a scatter plot and plot the mean point. The line of best fit should always go through the mean point. So we're going to use technology to find the mean point, which is just the mean of the x values and the mean of the y values. So first of all, let's call this x, and the heights will be y. We're looking to see if actual height depends on the predicted height. So we'll call it x and y, and then we'll type that into our calculator under stat, edit, and I've already got them typed in, so you just type them in L1 and L2. Just make sure everything's correct. If one of them's wrong, it's going to be a bit of a disaster, so make sure you have them all correct. And when you have that done, to get the mean point, you go to stat and go to calc, two variable statistics, and make sure it says L1 and L2. There's nothing in frequency list. Okay, and here comes a bunch of statistics. The average of the x values is on top. It's 6.03. So the average of the x's is 6.03. And the average of the y's, you have to scroll down. They got stuff like standard deviation in here, but you scroll down, you get the y statistics. So the average of the y values is 6.09. 6.09. So this means the mean point is 6.03, 6.09. Okay, so if we look at, we can also get we go to stat plot and turn the stat plot on. Click zoom 9 for statistic zoom. We get a scatter plot. So this is kind of what it looks like. Here is another way it looks like on this graph over here. So this is the scatter plot. This is the mean point. This is 6.0, what did we say? 3, 6.09. So you see the mean point is right in the middle of all the points because it's the average of all the x values and the y values of the point, right? So we need to draw a line through the mean point. And you don't want to draw it like just through here or here. You want to try to get it to follow the points and have approximately the same number of points above the line and below the line. Okay, so you do that by hand. And to get the equation of the line, you can pick 2 points on the line to find the equation. And they don't necessarily need to be these red points. Actually, it's probably better to pick a point that's far away from there. Now we know the mean point goes through it, so that's 1 point on the line. Let's just pick another point that looks like it's on the line. In this case, maybe we can even do the y-intercept, and maybe that would be pretty easy, or we could pick another point here. Let's say 2, 3 is on the line. Looks like approximately 2, 3. So let's find a slope first. A slope would be 6.09 minus 3 over 6.03 minus 2, which equals 3.09 over 4.03, which is, let's just type that into the calculator. Let me quit out of here. 3.09 divided by 4.03 is 767. So we have the slope. Let's get the y-intercept now, or let's write it in slope point form. So we have y minus 3 equals slope times x minus 2, point slope form. And so y equals 0.767x minus 2 times 0.767 and a plus 3. So let me figure out the rest of that now. So that's negative 2 times this number up here and plus 3. give me my y-intercept of 1.47, which looks about right on the graph. So this is 0.767x, and what do we say that was again? 1.447 plus 1.47. So there's the equation of our line of best fit, which is the best we could probably do by just looking at the graph. Let's see what technology can do. We're going to find a linear regression line, and I'm going to go to Stat, Calc, and then number 4 is linear regression. Make sure it says L1 and L2. Press enter a bunch of times. And we got R, the correlation coefficients on the bottom. It's 0.76, so it's a strong correlation. And here we have an equation y equals ax plus b, and it says, so we're very close. So this is the line of best fit we have circled here in blue, and in red I'm going to write the linear regression equation. It's y equals 0.747 x plus 1.59. Okay, so they're pretty similar.